Hi class, this is just a quick overview of the assignment for today. There's a Desmos activity and a Delta Math. It is reviewing exponential graphs or exponential functions and also logarithmic functions as well. So those topics are usually covered in Algebra 2, especially logarithms. They're usually introduced in Algebra 2, and then in pre-cal, we're gonna go in a lot more depth into logarithms when I'm back, and we'll look at operations with logarithms, how we can expand and condense and solve with logarithms. There's a lot more to do with logs. So the point of the Desmos activity here is more to be a little bit more of a review. However, if it's maybe exponentials and logs or maybe something that was not really covered much in Algebra 2 or kind of breezed over, it's supposed to be kind of an overview of that. So here on screen 2, you're going to click here. You'll make that prediction on the first screen, and then you will see the simulation by clicking that point to get to 21 days. Then on these are little kind of chaotic screens, but I'll just show you on this one. You want to click all these different features, the increase, decrease, the y-intercept, and the horizontal asymptote for this screen. So I'm going to click right here showing this is where it's increasing for this function, this 3 times 2 raised to the x power for this exponential. I'm going to click right here where that y-intercept is. And then the last thing, notice like I haven't gotten all the sunglasses on the faces. The last one's the horizontal asymptote, which is right there. So I know that's a very cluttered screen, but just to try to review those different features. And then same thing here is going to be very similar. Then here, what you want to do is change a certain value. It'll tell you what value to change. Like this one is telling you the b value. So notice if I change this to 3, not quite good enough. 4 is the correct value, and it shows you what that equation is. So that's what you'll be doing on some of those screens. Same thing here. Notice if I make this 1/2, it makes that exponential decay. So there's a few of those type of screens here. I'm going to jump ahead because you'll do those on your own. There's a card sort. On this type of card sort, you'll have parent function, like this parent function, and you want to drag all of the features, and you just have one stack. Okay, and also not all the cards will be used, and you can check your result over here. But they'll just with this one parent function card, you're going to match all the different features. So you just have like one stack and then some random cards that are not stacked together. Okay, and then it's going to start looking at a logarithm. So on this one, I want you to do a rough sketch of a logarithm. Basically just a reverse of those points, and you can kind of see I'm pretty close. It was log base 2 of x. And again, this is another screen where I want you to go through and click those different features. Notice for logarithms have vertical asymptotes, whereas exponentials have horizontal asymptotes. Again, more of those features. And then another card sort. Oops. Right here, the parent function is log base 10 of x. I know there's not a 10 there, but if you remember, just a log by itself is understood as base 10. So you're going to drag those different features. You'll have one stack related to all of log base 10. And then you have some cards that are not stacked. That's fine. You just have one group, and then you'll check your group here. And then right here, you're going to make some observations related to some exponential and log functions. So an example of an exponential e to the x, e is that natural number e, ln is the log of that. Those are just examples of exponentials and logs. After you get done with that, on Delta Math, there are just 2 little problem sets, and this is all for the week, but they're over exponential features and also logarithm features. So the first one's going to be focused on exponential, and then the second one will be for log. So I know it's a lot of blanks, but it's very repetitive. So on all of these first ones, this is an exponential function. So anytime you have an exponential function, you have to have a horizontal asymptote. It's just the feature of it, and you'll see it in the Desmos activity. If you have a horizontal asymptote, horizontal lines are y equals. Okay, so those, if it's exponential, you're gonna have to put horizontal and then y equals. Then you would just type the line, so 0. Then it asks for the range, so the y values. So this one's -infinity to 0. Its domain. Oh, well, before domain, this one's decreasing, and then the domain is all real numbers, right there. And then the end behavior. Okay, so on end behavior, the end behavior here is x goes to -infinity, and then this is as x goes to infinity. So let's look at the ends of the graph. Look at the arrows. So as x is going to -infinity, so right here, this arrow, notice that the arrow is pointing flat. It's going to 0. The y value is at 0. So y goes to 0. And then look at this arrow. This arrow is not pointing at a value. It's just pointing downward. downward meaning negative infinity. Okay, so again, a few blanks there. I think I gave you 3 attempts on those. On the next set are logs. So if it's a logarithm, that means you have a vertical asymptote. Vertical asymptotes or vertical lines are x equals. So let's see, for this one, it's going to be -8. So then we do range, domain, very similar as like the last problem. You're just looking at a new graph here. And then you would go through those steps again. Okay, so I paused the video just briefly to help me finish these so you're not just watching me solve the problem totally. But the range for this function, it's -8 to infinity. It's going down, so it's decreasing. The domain here, the range is all real numbers. I have those flipped. Going range up and down, all real numbers, but the domain is -8 to infinity. We can see like the smallest x value here is -8, goes to infinity. Up and down, it goes either direction. So I have those. So for in behavior, on the left side of the graph, notice here on the left, it's stopping at -8. For the x, for the y, it's just pointing upward. So I'm going to put to infinity. And then over here on the right side, notice the x values just keep getting bigger and bigger, and the y values are going downward, pointing more down. So x infinity, y negative infinity. So those are just one example of each for an exponential and a log. You have the Desmos activity and then the Delta Math, and that is all for the Wednesday assignment.